of a computer. So therefore, we're going to look at these resources in education. Now, you know that in our increasingly digital world that we live in today, the ICT plays a crucial role in education. And therefore, this lesson we look at the critical aspects of selecting or choosing appropriate ICT resources, and we are also going to explore the world of computer networks as an IT resource, their types, their benefits, and also their limitations. Now, let's move on to the factors to consider while you are selecting an ICT resource, because you may be selected as a team to decide on selecting ICT resources. Now, there are several factors which may influence your selection process. Number one is that learning objectives will be a major factor when selecting the ICT resources. That is, what specific learning outcomes do you want to achieve with the resource? Number two, the learner characteristic. You will consider the learner's learning style, the learner's prior knowledge, as well as the learner's technological skills, because you realize that different learners have different styles. Some are passive learners, some are active learners, etc. The learner's prior knowledge and also the technological skills. Does the learner know how to use computer devices? Those are some of the factors, among others, that you may look at when selecting an ICT resource. Additionally, we are going to look at available infrastructure. For example, what hardware are available? What software are available? Do you have internet connectivity in the school? Among others. Another factor is the teacher competency. Are teachers adequately trained to use the resource effectively? Are you trained to use this equipment? That should be a big factor. If not, then the teachers must be trained first. Then we also have the budget constraints. This is very important. What budget has the school allocated for the ICT resources? This will determine the type of ICT resource to buy. Another factor is the curriculum requirements. Now, looking at the curriculum, does the resource that you want to buy align with the national or local curriculum standards? Some resource could be above the national standard of curriculum. Others could be very low. Very low in terms of the curriculum standards of the country. The next point is the school policies. That is, are there any school policies that look at the use of ICT resources? So those are some of the factors that you must consider when selecting an IT resource for a school. Others include age appropriateness. That means the resource should be suitable for the age of the learner. Accessibility. That means the resource should be accessible to all learners, and this includes those with disabilities. Also, technical quality must be looked at. That is, the resource should be reliable, functional, and user-friendly to the learner. Now, also cost effectiveness. That is, you should evaluate, you should look at the cost of the resource in relation to its benefit. That means you must do a cost-benefit analysis and only select the resource when the benefits are way above the costs. Also, you should look at support and training. That is there support and training available for teachers and students in terms of the use of the resource? Another important factor is the privacy and security. That is, you must ensure that the resource respects the student's privacy as well as data security. So those are some of the factors that you must look at when you're selecting the ICT resources. Now we are going to move very quickly into one of the resources, that is computer networks. Now, what is a computer network? A computer network basically is a system where multiple computers are connected using either cables or wireless connection to each other in order to share information as well as resources. Now let's look at the characteristics of a computer network. Number one, we find that computers share resources. That is from one computer to another. That's one of the characteristics, that is resource sharing. This means that one can create files and store them in one computer and access those same files from a different computer which is connected to the network. Let's look at the classification of computer networks. Now, computer networks are basically classified based on the various factors. These include, number one, the geographical span. Number two, the interconnectivity. Number three, the administration of the network. And number four, the architecture of the network. Let's look at these one by one. Geographically, a network can be seen in one of the following categories. That is, a network may span across your table, that is, among Bluetooth-enabled devices, for example, your laptop or your phone or your speakers, and this range not more than few meters. A network may be spanned across a whole building. This may include intermediate devices to connect all floors, like routers and switches. A network may be spanned across a whole city, like the whole of Nairobi City, Kisumu City, Eldoret, Nakuru. A network can span across that city. A network may also be spanned across multiple cities or provinces. And finally, in terms of geographical span, a network may be covering the whole world. A good example is the internet, which covers the whole world. In terms of interconnectivity, components of a network can be connected to each other differently in some way. By this, we mean either logical interconnectivity, physical interconnectivity, or both physical and logical interconnectivity. That is, every single device on a network can be connected to any other device on the same network, and this creates a mesh type of network. Now, all devices can be connected to a single medium. However, they may be geographically disconnected, and this may create a bus-like structure. Now, each device may be connected to its left or right peers only, and this may create what we know as a linear structure. Now, in terms of administration, a network can be a private network which belongs to a single autonomous system and cannot be accessed outside its physical or logical domain. For example, our network at Alupe is a private network, which means only our students with the right password and the lecturers plus other staff belonging to Alupe can access the network because they have the password. Now, a network can also be public, which is accessed by everybody. Now, let's look at the types of computer network architecture. Now, a computer can be divided into various types. Computer network, rather, can be divided into various types. That is, a client-server network architecture, a peer-to-peer network architecture, or hybrid network architecture. Now, there can be one or more systems acting as a server, while the other being a client. Now, a client requests resources from the server, and the server provides whatever has been requested, the resource that has been requested, to the client. That means the server takes and processes the requests on behalf of the clients. That's called the client-server architecture. This means the client has the server has the resources. The client only requests for the resources, and the server provides those resources. Now again, two systems can be connected point to point or in the back-to-back way. In this case, they both reside at the same level, and therefore they are called peers. Now, looking at computer network types, generally, like we had explained earlier on, they could be based on the geographical span. Depending on the distance, for example, your mobile phone and its Bluetooth headphone, that's a small distance in terms of geography. And a network can be as large or as big as the internet itself, which covers the whole geographical world. So you could have a small network and a large network. Now let's look at the first one, the personal area network. A PAN is the smallest network which is very personal to a user. For example, it may include a headphone and a mobile phone, a laptop, and any Bluetooth device, for example, a speaker. This is called a personal area network due to its small geographical area. That's why it's called a personal area network. Now the PAN has connectivity range of up to 10 meters. An example may include wireless computer keyboard and mouse, Bluetooth enabled headphones, wireless printers, TV remotes, among others. Then the next one in terms of geographical area is the local area network. This means that a network which spans just inside a building and operates under a single administrative system is generally known as a local area network. In most cases, the LAN covers an organization's office, a school, a college, or a university. Therefore, our university has our own local area network. Now, the number of systems that can be connected to a LAN may vary as from 2 computers to as much as 16 million devices. So this local area network generally provides a way of sharing resources between the end users. Now, the local area networks are basically composed of inexpensive networking and routing equipment. Sometimes the LAN may contain local servers serving file storage and other locally shared applications. For example, at our university we have the ERP. It's an application that is shared by the members of Alupe, and therefore it is contained in our local server within our local area network. Now the LAN uses either Ethernet or token ring technology, although the Ethernet is the most widely employed LAN technology and uses a star topology or a star arrangement, as we shall see later. Now the local area networks can be either wired, which means the cables are connected. They can be wireless, or both wireless and cabled at the same time. If you go to our university, you find that we have cabled sections and wireless sections where you can access from anywhere within the local area network. Next, we have the metropolitan area network, otherwise called a MAN, M-A-N. This generally expands throughout a city, such as a TV network, which can be either Ethernet, token ring, or fiber distributed data interface. The next one, which covers the whole world, is the wide area network, otherwise known as the WAN. The wide area network covers a wide area which may span across counties, or even a whole country, or a whole world. Now, telecommunication networks basically are wide area networks, as they provide connectivity to MANs and LANs. Now, what's the meaning of internetwork? This is a network of networks, and it's normally called the internetwork, or simply the internet. So this internet is the largest network in existence on this planet. It connects basically all wide area networks, and it can have connections to local area networks and home networks. Now, the internet uses a protocol known as the TCP/IP protocol, and uses the IP, that's Internet Protocol, as its addressing protocol. Now, the present day internet is widely implemented using Internet Protocol version 4. However, because of the shortage of the address spaces, people are already migrating from IPv4 to IPv6. That is Internet Protocol version 4 to Internet Protocol version 6. Now, the internet enables its users to share and access any mass amount of information all over the world. It uses www, that's World Wide Web, comma. It may also use File Transfer Protocol, FTP, email services, audio and video streaming, among others. Now, we find that the internet works basically on a client-server model. So anytime you request resource from the internet, you are the client, and the servers in the internet are the servers. So you're the client and they're the servers. Now, the internet is widely deployed on the World Wide Web services. This use the HTML linked pages, that is the HTML pages, that is hypertext markup language. These are linked pages which are accessible by client software known as the web browsers. So when a user requests a page using a web browser, like Google Chrome, for example, which is located in some web server anywhere in the world, the web server can respond with a proper HTML page. So the internet serves many purposes, and it also involves in many aspects of life. For example, we have email, instant messaging, we have bloggers, we have social media, marketing, networking, resource sharing, among others. Now let's look at some of the network LAN technologies. One of the technologies is called the Ethernet. So basically the Ethernet shares media. That is, it is a network, so it's a technology which uses shared media and has high probability of data collision. So the Ethernet uses something called the carrier sense multiple access stroke collision detection technology. This CSMA/CD technology is used to detect collisions. Now, on the occurrence of a collision in the Internet, all its hosts roll back to wait for some random amount of time and then retransmit data. Now the Ethernet provides a transmission speed of up to 10 Mbps, that is 10 megabytes per second, and it uses the coaxial cable or Cat5 twisted pair cable with an RJ45 connector. Now the Ethernet are cabled and they have an outlet on the wall. They have a socket on the wall. So on that socket, there's an RJ5 connector that moves into it. Normally, Ethernet follows a star topology with a segment length of up to 100 meters. So when you're cabling Ethernet, the maximum length is 100 meters before you terminate it. Now all devices are connected to a hub or a switch in a star type of way. Now let's look at network topologies. Now a topology is the arrangement in which a computer system or network device, be it a printer, be it a router, are connected to each other. Topologies may define both physical and logical aspects of the network. Let's look at the first topology or arrangement of the computer nodes on a network. We have number one, point-to-point topology. Now the point-to-point network topology contains exactly two hosts, e.g. a computer, a switch or router, or servers connected back to back using a single piece of cable. Now if the hosts are connected point to point logically, then they may have multiple intermediate cables. Now look at the image on the screen. We have a point-to-point topology where we have two computers or workstations which are linked using a single cable. The next is a bus topology. In case of a bus topology, all devices share a single communication line or cable, and this topology may always have a problem, especially when multiple hosts are sending data at the same time. Now, looking at the image, you can see a single cable, this line here, this is the backbone, and then each computer is connected individually from the main cable. You can see that, you can see that, you can see that, but this is the main backbone. This is called a bus topology. Now we have also a star topology, that is, all hosts in a star topology are connected to a central device. This central device is known as a hub, and also these devices are connected to the hub using a point-to-point connection. So let's look at a star topology. So you can see this is the central hub, this one, and these are hosts. We have 6 hosts here and a central hub. So they are connected on a point-to-point to the hub, as you can see. Point-to-point connection to the hub. That's a star topology. Then we have a ring topology. In a ring topology, each host connects to exactly 2 other machines or computers. So each computer or each device connects to 2 other devices or computer machines, and thereby creating a circular network structure. Now, failure of any host or any computer in this type of network results in the failure of the whole ring, the whole network. This is because every connection in the ring is a point of failure. So let's look at the image. So you can see here we have 1, 2, 3, 4, 5, 6. There are 6 hosts that are sharing data back and forth, that are sharing resources back and forth. So should any computer have problems, then the whole of this network will fail, will go down, because they're in the path of the data transmission. Then we have the mesh topology. In this type of arrangement, a host is connected to one or more multiple hosts. Typically, this topology has hosts in a point-to-point connection with every other host, or may also have hosts which are in a point-to-point connection with a few hosts only. So let's look at the mesh topology. So you can see we have hosts all over, and they are connected to each other hosts, thereby forming a mesh kind of arrangement. Now let's look at the computer network security, because this is very important. Now, we find that all security threats on a network are intentional. That is, they occur only if intentionally triggered. Now, these threats can be divided into the following categories. Number 1, we could have interruptions, we could have privacy breaches, we could have issues of integrity, and we could also have issues of authenticity. Let's look at the first one, interruption. This means a security threat in which availability of resources is attacked. For example, you wanted to access a web server. You requested for a resource on a web server, but you cannot access it. That is known as interruption. Then there's the privacy breach, whereby the privacy of a user is compromised. That means somebody who is not the authorized person is accessing or intercepting the data or the resource sent or received by the original authenticated user. That's called privacy breach, which means somebody can now access your data and your resource. Somebody who is not authorized can access your data or resource. Then let's look at integrity. This is a type of threat which includes any alteration or modification in the original context of communication. That is, the attacker intercepts and receives the data sent by the sender and now, interruption is a security threat in which availability of resources is attacked. For example, a user is unable to access its web server, or the web server is hijacked. When we look at privacy breach, this is a threat in which the privacy of a user is compromised. That is, someone who is not authorized is accessing or intercepting data which is sent or received by the original authenticated user. This means that an unauthorized person can access your data or your resource. That's called privacy breach. So let's talk about integrity. Let's talk about integrity. In this type of threat, any alteration or modification of the original context of communication is realized. That is, the attacker intercepts and receives the data sent by the sender, and the attacker then can either modify or generate false data and sends to the receiver. So the receiver receives the data assuming that it's being sent by the original sender. This is called integrity type of insecurity. Then authenticity. This is where a threat occurs when an attacker or a security violator poses as a genuine person and accesses the resources or communicates with the other genuine users. Now, these other genuine users imagine that the other violator is one of them. Therefore, it brings the authenticity issues. Now, how do we secure computer networks? Number one, we have cryptography, which is a technique for encrypting plain text data, which makes it difficult to understand and interpret. Now we have several cryptographic algorithms which are available. Number one, we have a secret key algorithm or formula. We have a public key algorithm or formula, and we have the message digest algorithm or formula. Now, the secret key encryption algorithm means that both the sender and the receiver have one secret key. This key is used to encrypt the data at sender's end. After the data is encrypted, it is sent to the receiver in a corrupted form. Now, because the receiver has the secret key, the corrupted form of data being sent is decrypted. So the sender encrypts the document and the receiver decrypts the document, which means the sender corrupts that kind of message or whatever is being sent, so that any other person who may intercept the document may be able to read, because it is corrupted. Now, when the person receiving the data, the message, the resource, receives it, then he uses the secret key to decrypt. So it means it comes from the corrupted format back to the readable format. Then there's the public key encryption, whereby in this system, every user on the net has its own secret key, and it is not in the shared domain. That means the secret key is never revealed in the public domain. Now, the public keys are always made public and is used by the senders to encrypt data. When the user receives the encrypted data, he can easily decrypt it by using its own secret key. And then we have the message digest, where in this method, actual data